Hello everyone, my name is Michael Tippy. I'm a member of Team01, also known as Team Space JAMM. Thank you for joining us for this demonstration of our proposed power solution for a hypothesized surface explorer.
The overall objective of Team Space JAMM's project was to design and demonstrate a functional energy source option for a hypothesized surface explorer, specifically for any subsequent Psyche exploration missions that could take place in the future. As a group, we collectively analyzed the specifics of space power technology, as well as Psyche's characteristics and environment, to assess what a realistic solution would look like. Distance from the sun, irregular shape, asteroid composition. It was pretty apparent that we would require an out-of-the-box concept to overcome some of the limiting factors and restrictions to establish an ideal power solution. So the team began to brainstorm, and we realized that industry has been progressing and making amazing advancements in laser to solar technology. We thought that if we could integrate an enhanced laser system into a standard spacecraft, that it would allow us to generate power in harsh and distant environments. In addition, incorporating traditional power options and technology could also provide a more robust and flexible approach to space power generation. And that is how we established the Solar Laser System, or SoLaS. Simply put, it consists of an orbiter powered by its own solar cells that is capable of delivering energy via laser transmission to a solar cell located on a terrain-based power station and/or the surface explorer itself. Now, our team would have loved to build a 2-scale prototype, but due to budgetary constraints in the project timeline, that just wasn't possible. So we decided to scale down the design and focus primarily on 2 key points to prove the design's functionality: utilizing the laser to transmit energy to successfully generate power via a solar cell, and the system's ability to transfer that power to a battery and/or charging component. That being said, let me hand it over to Michael A. so he can explain exactly how we were able to accomplish that. Michael?
Thank you, Tippy. Like he said, I'm Michael Anderson, a member of Team 1 Space Jam, and I'll be going into more detail regarding our prototype solution method. Like he stated, the overall concept involves an orbiting satellite with solar arrays to capture solar energy. Then, using a laser beam director to target a ground receiving unit, the satellite will transmit this energy to the surface using a laser beam, enabling ground rover missions on Psyche, or virtually any celestial body. This solution solves many problems of traditional solar-powered rovers, as we are able to utilize the position of the satellite to overcome geographical challenges and dark zones to explore hard-to-reach places. Our solution prototype consists of 2 major systems, the transmitter and receiver. The primary subsystems are the power supply, the laser diode and direction system, PV cell array, the power controller, data logger, and finally the surface battery power storage. This innovative solution is much different than the common solar-powered surface rover, and this system architecture works together to achieve our project's goal of providing power to the surface explorer no matter where on the surface it is located and Psyche. Focusing on the transmitter, the primary objectives that this system will accomplish are to receive our initial input power to the system, to then direct this power to the laser diode, to accurately deliver the beam to our ground receiver, and to transfer this power via laser beam to the surface of Psyche. This method will demonstrate our ability to focus the energy into a beam and direct the energy to the surface, allowing precise placement of power wherever it is needed. Our transmitter laser diode has been selected with a 5-watt power output and a 450 nanometer wavelength. The laser is mounted on a pan and tilt hat, enabling the beam to converge into a beam spreading lens attached to the receiver. This beam direction system could also be utilized to focus our power beam wherever necessary to power missions on Psyche. We have noticed upon testing that the prototype gets very warm in operation, and we have overcome this with fans to provide cooling. However, this would not be an issue on Psyche due to the extreme cold temperatures there. The receiver's accomplished objectives are to capture the transmitted energy, to store it for later use, or to directly power the surface explorer. The power received through the PV cells is conditioned in a power charge controller that enables us to transfer the power to our battery storage bank for data collection and ultimately for use with our surface explorer. We utilize data logging software to analyze system performance and efficiency. This receiver is the primary method of capturing the power from the satellite. However, if the rover were to be out of battery and not docked to the receiver substation, we have the ability to remotely power the rover by directing the beam to the rover using beam steering on board the satellite. The PV cells we have selected are 6-volt, 3.5-watt panels. This ultimately gives us sufficient power to demonstrate capability and prove the concept, although clearly we would need much more powerful cells and lasers to implement this on Psyche and perform a proper scientific mission. We have a glass beam spreading lens that will allow the beam to be spread to ensure full coverage of the PV panel, so we minimize overshoot and underutilization of the system. We use an Arduino Uno to sample and record data on the performance of the system. The power is then delivered to our 3.7-volt, 500 milliamp hour lithium-ion polymer battery storage bank that completes the proof of concept. The test is performed in a controlled environment to ensure minimal light intrusion. The system is powered on and the laser beam is directed towards the receiver and into the lens. The lens will spread the beam over the area of the receiving PV cell array. The power is then sampled and monitored, and then conditioned and transferred into our lithium-ion battery storage bank for later use. We observed about 1 watt continuous power transfer with at peak around 20% system efficiency. Over time, our sampling demonstrated that the battery voltage increases, indicating that the charge is occurring. And now to team member Anthony White for more on our testing. Anthony?
Thank you, Michael. Hello, my name is Anthony White. I'll be presenting the team's discussion on the results previously reported. After extensive testing, the team was able to successfully transmit power wirelessly over a scaled distance. Since it is not reasonable to test over an extended distance, given the laser the budget was able to provide, the team was able to transmit power over a range of 5 to 10 feet. As shown in the figure, we were able to sustain reliable power transmission of around 1 watt over a period of 16 seconds. Because this test was done on Earth, the conclusion from this testing suggests that if done with a more efficient laser and in an environment closer to free space, the power transmission would surely exceed a sustained average of 1 watt. Still, we have shown that our system is dependable, meeting our requirement that SoLaS is reliable. Furthermore, another system requirement was met during this phase of testing. The system, integrated with a LiPo battery and charger, was able to successfully store charge in the battery. This is a significant outcome. The entire system's purpose is not only meant to transmit power, but also store it for later use, especially during Psyche's eclipse period, where the orbiter would have no visual access to the Surface Explorer's solar panels. Here, we see a sustained average transmission efficiency of 20%. This is a noteworthy outcome. Not only did this efficiency exceed our expectations of 10 to 15%, but this again shows the reliability of the system. SoLaS would not be utilized at all if it were not efficient, so demonstrating its proficiency in transmitting power is momentous, especially noting that it's a persistent efficiency. So, once further work is done with more advanced hardware, such as lasers, solar panels, and sensors, it is exciting to think of what efficiency numbers we might see then. Over the course of designing, building, and testing, it became more clear how important it was to have quality hardware. Due to the budget constraints, the team was inhibited by what the budget can afford. Even with an additional increase in finances, lasers and solar panels tend to be expensive at the start, and prices only increase exponentially when considering efficiency and power. Increasing the budget would allow for hardware that would afford a better match between laser wavelength and solar panel absorption ratings. These alone would show a huge increase in power transmission numbers. The team wanted to, but was unable to, perform testing in which the light source was varied. This would allow for more data and thus insight into the system. The team identified a point of improvement for the system, a more efficient energy storage system for batteries. Again, a larger budget would afford a better charging sensor. And finally, based on the testing, we learned that power transmission over a distance is reliable, practical, and promising. The impact of SoLaS goes far beyond the Psyche mission. Because the system incorporates cheap and effective power generation, this would open up an entirely new age of space exploration. Cheap power is the biggest contributing factor for deep space mission formulation and success. Cheap and reliable power would be the biggest factor in determining if a mission is feasible. Incorporation of SoLaS in future missions would allow for an expansion and exploration within our solar system. So, sending a surface explorer to traverse the asteroid's surface will not only deepen society's understanding of our universe as it collects, samples, tests, and conducts scientific experiments, but it would invigorate a new kind of space race, leading to jobs and eventually knowledge. SoLaS is a grand idea. An idea that would take a team numbering in the hundreds. Not only are we designing a new laser, but we're testing solar panels, energy storage and distribution, control systems, computer vision. Future work involves the work of engineers and scientists to perform scaled testing with longer distances, more powerful lasers, and efficient panels. Testing environments closer to that of Psyche's surface, simulating its cold metal surface and truly seeing the feasibility of the system in deep space. Thank you.